So we're now moving on to series, and a series is the sum of the terms of a sequence. So remember, the sum means to add together. The sum of a series we can sometimes represent using sigma notation. So we have the sigma symbol, which is that big E looking thing, which in math means the sum of. Now, the number at the top, the 5, in this, what I've got written here, is the upper limit. So that's where we will stop. The number at the bottom is the lower limit, and sometimes you may see a variable equals the lower limit. Sometimes it will just have the number. They mean the same thing. If it's got a variable, it just means that the variable is starting at that number and it's going to the number at the top of the symbol. And then you got the general term. Here I've got written 3n minus 2, but that can be any equation. So it just means that when we are doing the sum, in this example, we will be starting at term 1 and we will be adding all the values all the way up to term 5. Now these questions here are straight from your booklet. I will go through a couple of them and then you can carry on with the rest. So number 1, consider the sequence 3, 5, 8, 11, 19. We want to find U3, then S3, then U5 and S5. So for number 1, A, U3. So remember U means our term. So U3 is a third term. So just write that here, just so as a reminder, just in case you're not sure. So U3 is a third term. So U3 would equal, look at the numbers, the third term is the third one across, which is 8. Now S3 equals the sum of the first 3 terms. So S3 would equal the sum of the first 3 terms. The first 3 terms are 3, 5 and 8, so it would be 3 plus 5 plus 8. And that equals 16. So that's the difference between a term number and the sum. Then same thing for part C. Part C, we want to find U5, so we just find for the 5th term, which is 19. And part D, we want S5, which is the sum of the first 5 terms, so it'd be 3 plus 5 plus 8 plus 11 plus 19. Then if you add that all together, you get 46. And that's how it works. I'll just do 2A, and then you can carry on with B, C, D and have a go at question 3. So we've got 2A, and our formula is UN equals 2n plus 3. Part 1, we want to find the first 4 terms of the sequence. So we want to find U1, U2, U3 and U4. So U1 would equal 2 times 1 plus 3, which would be 5. U2 equals 2 times 2 plus 3, which is 7. U3 would equal 2 times 3 plus 3, which equals 9, and U4 equals 2 times 4 plus 3, which equals 11. Now part 2 wants us to find S4, which means the sum of the first 4 terms. So S4 would equal 5 plus 7 plus 9 plus 11. So the first term plus the second term plus the third term plus the fourth term. And if you work that out, you will get 32. And that's how it works with the series. So have a go at the rest of the questions before we go on to arithmetic series and geometric series. Arithmetic series. So depending on the information given, there are 2 formulas that we can use to find the sum of an arithmetic series. These are both given in IB formula booklets as well. So you've got the first one, which is Sn equals n over 2 multiplied by un plus un. So that's if we know the first term and we know the last term that we're trying to find the sum of. So say we're trying to find the sum of the first 5 terms and we know the first term and the 5th term. Then we can use that formula. Or we can use Sn equals n over 2 brackets and then multiply that by 2 times u1 plus n minus 1d. So example 1, an arithmetic series has 8 terms. The first term is 3 and the last term is 17. Find the sum of the series. So in this one we know the first term and the last term that we want to find. So we will use the first equation. So we will use Sn equals n over 2 multiplied by u1 plus un. Now find the sum of the series. So this series has 8 terms, so we're trying to find S8, which will equal n. So that's our how many terms we've got. So that'll be 8 over 2 multiplied by the first term, which is 3, plus the last term, which is 17. So the 8th term is 17. And then you just work that out. So that'll be 20 times 4, which is 80. Example 2. Find the sum of 1 plus 5 plus 9 plus 13 all the way up to 30 terms. So we don't know what the 30th term in this situation. So we're going to use the second formula from above. So that was Sn equals n over 2 multiplied by 2 times u1 plus n minus 1 multiplied by d. Now we need to make sure we've got all our information that we need. So u1 will equal 1. N, how many terms? We're going up to 30 terms. And our difference we just need to work out. So remember we do, say the second term minus the first term, which equals 4. So it's going up by 4 each time. And then we can just put all that information into our formula. So we want the S of 30, the sum of the 30 terms, equals, so n is 30 divided by 2, multiply 2 times by u1, which is 1, plus n, which is 30, minus 1, multiplied by our difference, which is 4. Put that in your calculator and you'll get 1,770. And then example 3, so we want to find the sum of 6 plus 10 plus 14 plus 18 all the way up to 102. So with this one, we know the first and the last term, which means we want to be looking at this formula. But we do only know what the first and the last term are. So we know that u1 equals 6 and we know that un equals 102, but we don't actually know what n is. So we need to work out n first, which means we need to go back to our original formula, sub values in, and then work out what n is. So we know that un equals u1 plus n minus 1 times by d. We know our un is 102. We know that's our final term. We know that u1 is 6. We're trying to find n. And if we look at the sequence above, it's going 6, 10, 14. It's going up by 4 each time, so our d is 4. And then we just solve for n. So we'll have 96 equals 4n minus 4. Once we've expanded the brackets, I've taken the 6 across already. Add the 4, we'll get 100 equals 4n. So n equals 25, 100 divided by 4. So now we've got that, we can sub that into our formula. So we're wanting to find the sum of the 25 terms. So that will equal 25 divided by 2, multiplied by u1, which is 6, plus un, which is 102. Put that in a calculator and you get 1,350. And that is arithmetic series. And now geometric series. So we have 2 different types. We've got a finite and we've got an infinite. So in the finite geometric series, there's these 2 formulas. They are actually, if you look at them, pretty much the exact same thing. It's just the 1 and the r are the opposite way around. Now, you can use either of these formulas. Generally, it's easiest to use the first formula if r is greater than 1, and the second formula if r is less than 1, because it means you get rid of any negatives, but it realistically doesn't matter. So let's have a look at a couple of examples. So the first example, find the sum of 3, 6, 12, 24, all the way up to 10 terms. So the first thing we need to look at is it a geometric sequence? So it's going 3, 6, 12, 24, and you notice it's being multiplied by 2 each time, so it is geometric. So let's start with our formula. So we have Sn equals u1 multiplied by r to the power of n minus 1 all over r minus 1. Now let's make sure we have all our information. So we know we want 10 terms, so n equals 10. u1, our first term, equals 3. Now our r, we need to work out our ratio. So remember, you can do the second term divided by the first term, or you could do the third term divided by the second term, your choice, which equals 2. And we can just sub our information in. So we're wanting S of 10 equals U1, which is 3, multiplied by R, 2, to the power of N, which is 10, minus 1, all divided by 10 minus 1. Put that straight into your calculator and you get 3069. Now, part B, we've got 8, then it's going minus 4, then it's going plus 2, then minus 1. And we want to add all these terms up to the 7th term. So if we look first, we know that our U1, our first term, is 8. Our N is 7, because we're wanting 7 terms added together. Now our R, minus 4 divided by 8, which equals minus a half. Now because our R value is now less than 1, it's a half, minus a half, we can use the second version of the formula. But as I said, you could use the one we used in part A. It honestly doesn't matter. So, but I'm going to show you with this one as well. So be Sn equals U1, open brackets of 1 minus R to the power of N, divided by 1 minus R. Put all our information in. So we want S7 equals U1, which is 8, 1 minus R, which is negative a half, to the power of N, which is 7, all divided by 1 minus negative a half. If you want, then you could simplify this down if you would prefer. You don't need to, but if you put that straight into your calculator, you will end up with 43 over 8. So just be careful with these ones, with your negatives, making sure you have brackets in the right place, etc. Now, the other type of geometric series you can have is an infinite geometric series. So an infinite geometric series is a sum of the terms of a geometric sequence which continues indefinitely. Now that sounds a bit strange. How can we add numbers that go on forever? And what you will find is if our R is greater than 1 or R is less than negative 1, the terms in the series will just get larger and larger, just as we saw before. The sum becomes infinitely large and we can't add them all together. We can't find it because it's an infinite amount. Now, what we call with a series like that, we could say it's diverging. So if the series is just getting bigger and bigger, like if we just go back up quickly, so like in part A here, it's going 3, 6, 12, 24. The numbers are just getting larger and larger. The series is diverging. Now, if our R value is between -1 and 1, that means the terms are actually getting smaller each time, because like if we looked at this one in part B, we got 8, then we go -4, then we go 2, -1. Each time the number is getting smaller and smaller. So when a series converges, the sum just gets closer and closer to a set value. Now remember, this only works for if R is between -1 and 1, and if it is, then our sum formula is Sn equals U1 divided by 1 minus R. So example 2 here, find the sum of 2 plus 1 plus a half plus a quarter plus ... because it's going on forever. But you see here, our numbers every time are halving, so they're just getting smaller and smaller, but they're actually approaching a set value. They'll never go past 0 because we're only adding positive numbers. So it's just going to get smaller and smaller and smaller and approach the number 0. So let's have a look at what the sum of this would be. So we know that Sn equals U1 over 1 minus R. And we just put our information in. So U1 is 2 divided by 1 minus R. So let's double check what R is. So R we can find in the second term divided by the first term. So it's just a half. So back to our formula, so it would be 2 divided by 1 minus a half. Put then your calculator and you get 4. So the sum of this is also approaching 4 and won't go past 4. So if you think about it, we have 2 plus 1, which is 3, plus a half, which would be 3.5, plus a quarter, which would be 3.75, and you just keep on adding, and you'll find it will never ever go past 4. It's approaching the number 4 is the sum. And that is geometric series.